In this video, I'm going to go through 4 linear equation word problems with you. So the first one on the screen shows the table has X, the number of pizzas that are ordered, and the Y table, Y column, shows the total cost. So you can see that the number of X's is increasing by 2, and the number of Y's is increasing by 20, right? So let's answer this first question here. It says, in this table, X represents, and X represents the number of pizzas ordered. And Y represents the total cost. Now to find the slope of this table, we need to do how much is the Y changing divided by how much is the X changing. Remember, the Y's are going up by 20 and the X's are going up by 2. So 20 divided by 2, the slope is 10. The Y-intercept is how much it would cost to buy 0 pizzas. So I'm going to look at that top row there. I'm buying 2 pizzas. And if they're $10 each, the slope is $10. They should be $20. But the total cost is $24. That must mean that the Y-intercept is $4. Let's check that with some other rows. Let's look at the second row. 4 times 10 is 40. 4 pizzas should cost $40, but because of that $4 Y-intercept, it actually costs 44. So the equation for this table is Y equals 10x plus 4. Now it says, what does the Y-intercept of this equation represent? What could, they're always adding $4 onto this table, so what could that represent if you're buying pizza? Well, I'm going to say the delivery cost. It could represent other things like charging for the box or charging for plates, or whatever you're buying. Also, it comes with a drink or something like that. Y-intercept always represents some sort of head start, some sort of thing that's always added. And the slope, what does the slope of $10 mean? Well, the slope of $10 means that pizzas cost $10 each. And what would the total of 9 pizzas cost? Well, we said pizzas are $9 each. So 9 pizzas at $10 each would cost $90. And then after you add the $4 delivery cost, or whatever that represents, it would be $94. So there you go. There's the answer to the first one. Now let's do the second one. This table, the X represents the number of hats being purchased, the number of hats being ordered, and the Y column represents the total cost. Now to find the slope, remember, we're going to do how much are the Y's increasing divided by how much are the X's increasing. The Y's are increasing by $45 each row, and the X's are increasing by 5. So 45 divided by 5, the slope is going to be $9. Now remember, to find the Y-intercept, pick one of the rows and multiply it by the slope. Pick one of the X's and multiply it by the slope. So I'm going to do the top row. 5 times 9 is 45, but they think the cost is $35. The Y-intercept is negative $10. Let's try the second row just to confirm this. 10 times the slope is 10 times 90, minus the $10 Y-intercept is 80. So the equation of this table is Y equals 9x minus 10. What would a negative 10 always be? Take it away from the total. What would that mean? A $10 coupon or a $10 credit? For some reason, they're taking $10 off of our bill, regardless of how many hats we order. And what does the slope represent? Well, the slope is $9. That's the cost per hat. And how much would 3 hats cost? Well, 3 hats at $9 each would be $27. After the coupon, it would be $17. And that's the second example. The third example says X is representing the number of apples picked, and Y is representing the total weight of the apple basket. To find the slope, we find how much the Y's are changing, then divide it by how much the X's are changing. 2, 7, 12, 17, those are all going up 5. Apples being picked, 2, 12, 22, 32, those all go up 10. So 5 divided by 10 is a half. The slope is a half. So that means I'm going to fill this one in now. That means that apples must weigh a half a pound each. So the y-intercept, if apples are half a pound each, 2 apples should weigh 1 pound, but they actually weigh 2. Weighs 1 more pound than it should. 12 apples should weigh 6 pounds, but it actually weighs 7. The y-intercept is 1. And what does that mean in this problem? That means that the basket, there's a weight when there's no apples. The basket must weigh 1 pound. It's a pretty heavy basket. And then the equation for this situation is y equals 1/2 x plus 1. That means if you want to know how much the basket weighs, you're going to cut the number of apples in half to get the weight of the apples, and then add 1 for the basket. So 36 apples would weigh 18 pounds. The basket weighs 1 pound. Altogether, this would weigh 19 pounds. And then finally, the last example here. Okay, for the last problem here, X represents the gigabytes of cell data used, and Y represents the cost of the cell phone bill. So if we look for the slope, the Y's are going up by 30 and the X's are going up by 6. 30 divided by 6 is 5. That means that the data must cost $5 per gigabyte. And if 3 gigabytes are $15 is what we think it should be. They think it should be $45. The y-intercept is 30. That means that there must be a flat rate of $30. Right? Regardless of how much data we use, it's going to cost $30 for this plan. 15 times 5 is 75. So this plan should only cost $75, but we have to add that $30 fee on. That's why it's 105. So the equation here is y equals 5x plus 30. 1 gigabyte would be 1 times 5, which is $5, plus the flat rate of 30. That would be $35. And y says explain, so it's $5 a gigabyte plus the $30 fee that is always added on. So there you go, there's example 4. That's all for today. Thank you for watching.